All right, in Unit 3.4, we're going to be looking at this, still continuing on this idea of polynomials and the zeros and the roots, the x-intercepts. And so to kind of start this concept off, let's put those all down together. So zeros, roots, solutions, and x-intercepts. Those are all the same thing. I know solutions is terribly sloppy there, but deal with that. Okay, so zeros, roots, solutions, x-intercepts. And we know that these guys right here lead us to our factors, or vice versa. If we have a factor, we can go over to our zero roots or x-intercepts. So in our mind, what we want to start establishing is that this idea that if I have a linear function, so if, like, for example, I had y equals x, that's going to have one x-intercept. If I had y equals, and this is not exactly x squared, and that's not exactly y equals x, but as a parent function, if I have an x squared, then we could have at most two zeros, two places across the x-axis. If we have a cubic function, this is a negative cubic, excuse me. Let's slip a little negative on the front of that. This is a negative cubic. We have 1, 2, 3, or at most, okay, have at most 3, or in this case here they say cannot have more real zeros than its degree, so no more than 3. And then this guy right here would be y equals something like x to the fourth. Obviously there's some variations because some transformations here, but you can see here 1, 2, 3, 4 times that guy would cross the x-axis. So as we're introducing polynomials here, let's kind of keep that train of thought in mind. Now, we're going to go take a look at some characteristics of these guys and you know, how we can determine different names of these. And so if you want to, probably the best thing is just kind of jot this down. I think it's valuable in the sense that, you know, it has all of this information that we need along the way, and so that you can take a look at it and say, okay, this is the things I need to know. So create a little, you know, little chart just like this in your notes and kind of follow along. So we'll wrap this video up with this piece, and then we'll start off on another one. All right, so standard form means that we're largest exponent to smallest exponent. So in standard form, this would be 8x squared plus 4x, excuse me, negative, and then the minus 7. So that would be standard form because it goes from 2, 1, nothing, no exponent. So it's in descending order. If we put this guy in standard form, that would be 9x to the 4th plus 2x. So it would be 4 to 1. This guy's already in standard form because it hasn't understood 1. This guy right here goes 3, 2, 1, none. So that's standard form. This only has one term. And then right here, technically, for the conversation purposes, this isn't even a function because of that exponent there, because of this guy. So we're going to go ahead and just kind of say that, hey, that's not even a function, and we'll come back to that. So that's not a function. We may talk about the characteristics of this, but because of the fact that that is 4 over x, the x is in the denominator, that makes it not a function. All right, and in this case here, that's in standard form. All right, so let's go through and identify some characteristics. So in this case here, the degree is the biggest exponent, so that's 2. To classify that by a degree, that would be called a quadratic. Okay, the leading coefficient, the coefficient or the number out in front is negative 8. The other coefficients are positive 4 because that's the other number that's in front of a variable. The other number in front of a variable. So a coefficient is a number in front of a variable. And then a constant is a number that doesn't have a variable by it. So in this case here, negative 7 is a constant. This particular polynomial has 3 terms, and so we call it a trinomial. All right, second one. My degree is 4. We classify that as a quartic. The leading coefficient is a 9. The other coefficient is a 2. And we don't have, we'll say, NA. There's not a constant because there doesn't exist a number without a variable on it. There are 2 terms, so we call that binomial. All right, next one, the degree is 1. We call that linear. Remember, it's an understood 1 on the x right there. The leading coefficient is -2/3. We don't have another coefficient because there aren't any other variables, but our constant is -7. There are 2 terms, so we call this a binomial. The next one, the degree is 3. We call that a cubic. The leading coefficient is -3. The other coefficients are 3 and -5. Yes, you can have more than one. The constant is 9. There are 4 terms. And when we go beyond 3 terms, we call it a polynomial. So once you go beyond 3, so we got bi, we got tri, and then when we get to 3 plus, we call it poly. So if there's 5 terms, it'd be called poly. 6 terms, poly. All right, the last one, or next one here, the degree is 5. We call that quintic. The leading coefficient is -5. There's not a coefficient, and there's not a constant. There's 1 term, and when there's 1 term, we call it monomial. And the next one, if we went ahead and named things, the degree for this guy would be 3. Classify that, that would be called a cubic. The leading coefficient would be 2. The coefficient will be 4. The constant will be -2. There are 3 terms, and that would be called trinomial. But remember that this is not a function because of that. So even though we name those characteristics, this would be considered not a function. But don't sweat that part. All right, there's 1 term here. Excuse me, my bad, I misread that. The degree is 0. So this is a mathematical definition that I'm about to tell you. That this 3/5 is the same thing as 3/5 times x to the 0. So what we're saying here is that that is a mathematical statement that we have in place, that we know that we can put that variable x to the 0 power. We know that if we take anything, no matter what, we take anything, 8, and we raise it to the 0 power, we get 1. 10 raised to the 0 power, we get 1. -5 raised to the 0 power, we get, oops, let me do that right, -5 raised to the 0 power is 1. Anything, a fraction, 3/5 raised to the 0 power is 1. So a variable raised to a 0 power is equal to 1. And so what we're doing here is we're just using a mathematical definition so that we can see that the degree is equal to 0. In that case here, this is called a constant. The coefficient, there's not one. Leading coefficient, there's not a coefficient. There is a constant, however, that is 3/5. There's 1 term, and we call that mono. All right, so those are some characteristics, and basically you just want that there, some familiarity for vocabulary purposes as we're moving through this section.